Hello, this is Peter from Educomondo and a warm welcome to our STEAM project number 20, in which we will build a portable weather station capable of showing temperature and humidity. These lessons are for the absolute beginning STEAM teacher. No prior knowledge of programming or electronics is required. We call this level the Explorer level. The goal of today is to teach how students can integrate sensors and show data on a display. We will use the combined temperature and humidity sensor DHT11. We will need to work with the correct library, and we will rehearse working with the 16:2 liquid crystal display. But most importantly, your class will work as a team and develop their competency in microcontrollers. Let us take a closer look at the DHT11. This is a very popular sensor combining temperature and humidity readings. Most of the time, the sensor is already mounted on a small print with 3 output pins. There is the 5-volt power connection, the ground connection, and a signal connection. You will notice that the sensor itself has 4 output pins. Well, one is simply not connected. The sensor is built around 3 main components: a thermistor temperature sensor, a humidity sensor, and a small onboard chip. The temperature sensor and the humidity sensor are based on the change in resistance and capacitance when the temperature or the humidity changes. This analog resistivity change is transformed into a digital signal by the onboard chip and sent to the digital pin. Because this is the only new component that we introduce in this lesson, we can start distributing what we need for our weather station project. We have the microcontroller and the breadboard, the DHT11 sensor, the 16:2 LCD display, the DuPont cable with male and female endings, two small preformed wires, a black, red and yellow jumper cable, a 9-volt battery with a power plug, and, the most important, the cardboard figure of a cloud. We start by connecting the DuPont wire to the LCD display. Because our display is I2C enabled, we only need 4 wires: the power line, the ground wire, a serial data wire, and a serial clock wire. On the Arduino, we simply connect the data and clock wire to the right input pins. And how do we know which are the right pins? Well, they are labeled SDA and SCL. Because we have to power the display and the sensor, we will make a shared connection on the breadboard with the red and the black jumper cable. The red power and brown ground cable of the display is connected to the plus and minus rail of the breadboard. Now we connect the DHT11 sensor. The voltage pin is connected to the positive rail and the ground pin is connected to the negative rail of the breadboard. The signal pin is connected via this yellow jumper cable to digital pin number 5. And last but not least, we position the cardboard cloud over the temperature and humidity sensor. That's it for the hardware. Let's open up an Arduino sketch. We start by including the right library. And if it's not yet installed, go to the library and emphasize that the students use the correct library. As you can see, there are quite a number of libraries available for basically the same sensor, but not all of them will work. For our project, the students have to select the library called DHT-lib. As soon as the installation is finished, you can start by putting the name and the variables at the top of the sketch. So lesson number 20, weather station, variables and declarations. We include the libraries that we will use. It is liquidcrystal_I2C.h and DHT.h. Ask your students if they still remember how to create an object from the display library. We do that by typing liquidcrystal_I2C, and then we give the object a name, LCD, and in between rounded brackets we first put the address, then the number of characters and the number of lines. So 16 and 2. For the DHT library, we do exactly the same. We create an object and we will call it DHT, and to make the difference, we put everything in capital letters. So DHT, DHT. We have to define the pin from which the sensor signal will be read. We can use the format #define for that. So #define, and we give our pin number 5 the name DHT11_pin. Here we can also introduce and create a delay of 5 seconds. Let's go to the setup function. In the setup function, we initialize the LCD display by using the function lcd.init. And remember, we also need to set the backlight, lcd.backlight. That's it for the setup. In the loop function, we declare a value that will read the signal from our digital pin number 5, which we previously defined as DHT11_pin. So int val equals dht.read11, and in between rounded brackets our pin DHT11_pin. Now it just becomes a matter of telling the LCD display what to show. First, we set the cursor on the first position of the first row. So lcd.setCursor, and in between rounded brackets 0, 0. Then we can put some text in between quotation marks, for instance, humidity expressed in percentages. And next, we set the cursor to the first position of the second row by using the set cursor command and in between rounded brackets 0, 1. And here we print a variable that is generated by the library. We add that we want a decimal number, in other words, a float. So lcd.print, and in between rounded brackets, we create another rounded bracket where we put float, and then we tell that we have to read the humidity by dht.humidity. Because we want to show this number for some time, we use the delay dt, which we have set at the beginning to 5 seconds. So delay in between rounded brackets dt. And to avoid that characters remain on the display, we clear it by using lcd.clear. And now this starts all over for showing the temperature. We can copy-paste the previous lines and change humidity with temperature. Let's upload the program and see what our weather station is telling us. You can see the display changing between the humidity reading and the temperature reading. You can now disconnect the USB cable and connect the 9-volt battery. The weather station should continue to show the temperature and humidity reading even when you go outside. If it doesn't work, no panic. Let your students do some logical fault finding as in the past. Did you use the correct library? Is the potentiometer on the display correctly set? Were there any error messages in the Arduino IDE? Were there no loose wires or connections on the breadboard? Have you checked all components? And is there a proper USB connection between the computer and the microcontroller? Let's revisit the goals of today's lesson. The goal of today is to teach how students can integrate sensors and show data on a screen. We used a combined temperature and humidity sensor called the DHT11. We now know how to find the correct library and install it. We rehearsed working with the 16:2 liquid crystal display. And your class worked as a team and have been developing their competency in microcontrollers. I hope that you and your class enjoyed experimenting with this project. Time to wrap up with some assignment ideas. For instance, what are other measurements of temperature? What is the hottest temperature measured on our planet? What is the temperature of our sun? And what is the absolute lowest temperature? At what temperature is water boiling and freezing? So what is that temperature expressed in Fahrenheit and in Celsius? These are just some suggestions. As a teacher, you know your class best and you are ideally placed to come up with your own fun assignments. This concludes our Project 20, the Weather Station. It also concludes our Arduino-based competency in microcontroller series. You and your students are now ready to explore more sensors, write more complex programs, and combine the different elements that we have covered into new projects. Take care and bye bye for now.